Welcome back, guys. Today we are back with another problem, and today's problem is finding the shortest path in an undirected graph. So it's an interesting problem. We have to find the shortest path in an undirected graph. So it's a problem of graph, and it's a medium-based problem. It is also saying that the graph will have unit weight of the edges. Now our task is to find the shortest path from the source. So SRC equals to, you can write it as source, okay, to all the vertices, from 0 to all the vertices, and sometimes it can be unreachable to any vertex, then return -1 for that vertex. Okay, this is our base case. Okay, then return -1 for this particular thing. Okay, so how will I solve this particular problem, and what type of approach we are going to learn through this video? Okay, make sure to like, share, and subscribe to this particular channel, and it will help me grow, and it will help me provide more amazing contents for you guys. Okay, so let us come to this problem. Okay, so let us say, for example, take some coordinates, say 0, okay, say 1, okay, and 3. So if I connect the coordinates 0, 1, 3, 1, 2, okay, 3, 4, 4, 5, and we have a coordinate 6, okay, from 2 to 6, okay, and from 1 to 3, and from 6 to 7, and from 6 to 8, okay, and from 7 to 8 as well. Okay, so let us assume this graph, okay. So how we are going to solve the problem? So it is saying that we will be having unit weights. We'll be having unit weights. So I can have and add unit weights, means distance between 0 to 1. I can say 1 over here, 1, 1, 1. I can add a 1, okay, 1, 1, 1, 1, 1, 1. So imagine these are the distances between the weights. Now I'm going to create an adjacency list, which will help me give the node versus the particular nodes, which particular node are connected to, okay. So let us make an adjacency list. So how we are going to make the adjacency list? We can give it as adjacency list. Okay. So in this list, first you will see 0 is connected. So 0 is connected with 1 and 3. So I will put 1 and 3. Okay. Next come 1. My 1 is connected with 0, 2 and 3. Right. So I will write 0, 2 and 3. Next comes 2. So my 2 is connected with 1 and 6. Next 3 is connected with 0, 4 and 1. So I can write 1, 0, 1, 4. Next comes 4. 4 is connected to 3 and 5. 5 is connected to 4 and 6. You can check from this graph. And my 6 is connected with 7, 5, 8 and 2. So I will write 2, 5, 7 and 8, and my 7 is connected to 6 and 8, and lastly there will be 8 which is connected to 6 and 7. So that's a quite long adjacency list as per this graph. So how we are going to understand this? So basically we will be finding out the minimum shortest distance, right? So it's like we have to find the shortest path. So every time the path get updated, we need to put it inside an array. Okay, so we will be storing this in a distance array. Okay, so I'll write it over here, a distance array. Okay, a distance array. Okay, now distance array will be containing indices 0, 1, 2, 3, 4, 5, 6, 7, 8. Now I will say that why 8? Because our size is 9. So make sure the distance array has a size of 9, because there are total 8 nodes present inside this graph. Okay. So for that, initially, what my task is, I'll be putting a value as a large value. Okay. So I will be putting each of this nodes and their distances as, say, infinity. Okay. So I'll be putting an infinity over here in each of this distances present in the distance array. Okay. Now accordingly I will update. Okay. So let's see. And before doing that, we should be having a queue. We should be having a data structure which will store the values from start to top. Okay. So for that, I'll be making a queue. So let us imagine this to be pretty long. So we will be having a bigger queue. So yeah, I guess this will be enough to fit the queue values. Okay. So what are the elements? What are the things we will be having over here? We will be having the node and distance. We will be storing the node with their distance. Okay, so let us try and analyze this particular thing. Okay, so first is we have to check where node, what is our starting node. So if we check from the graph, the starting node, if we check from the graph, our starting node is 0 comma 0, right? So I'll be writing over here 0 comma 0. Okay, and now I have to calculate everything accordingly. Okay, so when I'm at node equals to 0 and when my distance is equals to 0, what are the nodes I am reachable to? Okay, what are the nodes I can reach? So I can reach node 1 and node 3, right? So I can reach node 1 and node 3. Okay, I can reach these two nodes, I can reach these two nodes. Okay, and you know that whenever I'm getting to a distance, I have to add plus 1, I have to add plus 1. That means my distance is updated, so my distance becomes over here 1 and 1. Okay, so the next element which I'll be adding after 0 comma 0 will be 1 comma 1 and 3 comma 1. Okay, so 1 comma 1 and 3 comma 1. Okay, now next node. So once my 0 is done, I'm going to slice it off like this and I'll proceed to the next element, which is 1 comma 1. So let us go with node equals to 1 and my current distance is equals to 1. So what are the elements I can connect from node equals to 1? I can connect to 3 elements, right? So the elements are 0, I can connect to the 2, and I can connect to the 3, as you can see from the graph. So there are 3 elements which I can connect, as you can see from the graph. So now these 3 elements have distance plus 1, okay? Plus 1, plus 1, plus 1. So my current distance will be, before doing that, let us check what we have got. So we have updated 1 with 1, right? So over here in the distance array, what I can say is, oh, 0 has been done. So I'm going to slice it off. I'm going to put a 0, infinity. From 1, my current distance which I achieved is also 1. Okay. And for the value 3, what is my current distance I have achieved is also 1. So this is my minimum distance from the source 0 to reach 1, and from source 0 to reach 3 is 1 currently. Okay. Now let us analyze this part. So now node 0 will be updated with a distance equals to 2. Over here, node 2 will be updated with an initial distance of 1 plus 1. So my distance will be 2. Similarly, for this, distance equals to 2. But if you check carefully, 0, 2, and 3 is there. But 3 is already covered up. And 3 has a minimum distance 1, which is obviously lesser than 2 over here. So we are not going to update the distance of 3. So we'll be just updating the distance of 2 with 2. Okay. So we'll be updating it with 2. Okay. So now let us come with the other nodes, and we have to fill the queue as well. So we have covered up with 1 comma 1. We have done 3 comma 1 as well. Okay. We have done 3 comma 1. So for 1 and 1, we have completed it, right? For 3 and 1, what are the values we are getting? We are getting a 0 comma 2, which is not required. We are getting a 2 comma 2, which is required. So I'll be putting 2 comma 2 over here on the top. Okay. Now my next is node 3 comma 1. That means my node value is equals to 3 and my distance equals to 1. So let us check in the graph what are my nodes 3 is connecting. My node 3 is connecting 0 and 4 and 0, 4 and 1. So 1 is already done, so I can bother about 0 and 4. So if I'm bothering about 0 and 4, 0 and 4, what I can see is I have to update the distance plus 1. I have to update the distance plus 1. Okay. So initially node 0 is 0. So my distance will become my node 0. Okay. So my distance will become distance equals to 1 plus 1, which is 2. And for here, in this case, my distance will become 2. Okay. So I have to update that for 4 I'm getting a distance as 2. So over here I'm going to put 4 comma 2, and for 4 I have to update it and make it 2. Okay. Similarly, I'm done with this, so I can cross out 3 comma 1. Now let's come to 2 comma 2, which is there in our next set of problems. So for node equals to 2, our distance is equals to also 2. Okay. Now let us see where is 2 connected to. 2 from the adjacency list is connected to 1 and 6. 2 is connected to 1 and 6. Okay. 2 initially has a distance 2. So for every value we have to add plus 1. So for distance equals to 0, we'll be having a distance as 3, and over here we will be having a distance as 3. Okay. So for node 6, we are going to update 6 comma 3, right? We are going to update 6 comma 3. So we'll be putting 6 comma 3 over here, and in our distance array calculation, we are going to update this with 3. Okay. As we are not updating the other values as they're already filled with their minimums. Okay. So we are done with we are done with 2 comma 2. We are done with 2 comma 2. Now let us go with node 4 comma 2. Okay, node equals to 4 comma 2. So node equals to 4, distance equals to 2. So what are the nodes connected by 4? 3 and 5. So I can write 3 and I can write 5. Now, as you can see, 3 has been already covered up, but still I'm going to update. So my current distance for 3 will be 2 plus 1. Every time, whenever I'm doing this, I have to add plus 1. So this distance will become 3 and this distance will become 3. So for 5, my distance has to be updated. So I can write after 6 comma 3 as a value 5 comma 3 and 4 comma 2, I can slash it out and I can update this 5 infinity over here as 3. Okay. Now let us see for our seventh node. Okay, so after before coming to the seventh node, we have to go to node 6 comma 3. So 6 is connected to 2, 5, 7, and 8. So I can write it over here. Node equals to 6, distance equals to node equals to 6 and distance equals to 3. So for 6, 6 is connected to a lot of components. 6 is connected to 2, 5, 7, and 8. 6 is connected to 2, 5, 7, and 8. So in case of every time I have to add a plus 1, so the distance, I can write distance equals to over here, it will become 2 plus 3 plus 1, which is 4. Over here, it will become 4, 4, and 4. Okay. But what I have to check is what are the values which I've already filled. So which are the values which I have not filled is 7 and 8. So I'm going to update this. I'm going to update this with 7 comma 4. I'm going to update this with 7 comma 4 and 8 comma 4. So both 7 and 4, 8 are updated to their maximum minimum values. Now I'm left with after is the node 7 and 8. So if I am going to traverse node 7 and 8, what I will be getting eventually is some values which are obviously greater than the values present over here. So I'm not going to waste my time into finding out the values. Now what I can conclude is, say for example, you want to go from 0 to the particular node, say 4. Okay, 0 to 4. What is the shortest path you can take? You can take a long path like this and come. So it will give you a longer value. You can take this path and come, it will give 3. But if you take the shortest path, it will only give 1 plus 1, which is 2. So this is what my goal is. My goal is to find the shortest path. And here I have updated the shortest path from reaching the source to any of the destinations. Say we have to reach from source 0 to source say 5. So for 5, I'll be only covering up 3 units, which is 1, 2, and 3. I'll not be taking a longer path. So this is optimally most optimal solution. And what is this technique known as? So this technique is known as a plane. This technique is known as, it's a very famous technique. It's known as a breadth first search. Breadth. Okay, we can coin it as breadth first search. Okay, we can coin it as BFS. BFS. Okay, so without wasting our time, let us go and finish the coding and implementation part of this particular problem. Okay, so this is the part where we start with the coding and implementation. So as you can see, we'll be given a function of shortest path with edges and weights. So just quickly switching to dark mode, so it'll be easier. So over here, I'll be giving a shortest path. So I'll be taking array list, okay, of array list, okay, and I will be taking this array list of the type integer. I'll be taking array list of type integer, and I'll be taking array list of type integer. You can say ID adjacency list. So I will be making an adjacency list of new array list. So over here, new array list is being made. Okay. Once this is made, I equals to 0, I less than, and I plus plus. In the adjacency list, I have to add new array list. Okay. And once the for loop is completed, I can add int equals to 0, I less than m plus plus, okay, dot get. So I will be populating my graph. So for populating, I can write edges. So in the edges, what I will be using 0, and for populating, I will be adding I 0, okay, and I can just add, I can just add the edges, add edges. So in the edges, I have to write in 0, okay, in 0. So technically, I can write I and 1, right? So for, yeah, I will just just take a part of this. I will 0, 0, I and 1. So first is I0, I1, and the second one will be I and 1, I and 1, I and 1, and I and 0, I and 0. Okay. So here goes my for loop. So I'll be now making the distance array, which I will be initializing with infinite values. So in the distance array, say I'll be initializing I equals to 0, I less than n, plus plus, okay, plus plus, and I will be initializing this I with a very large value. So very large value of 1e9. Okay, so I will be taking the distance as source equals to 0. Okay, I'll be taking my distance as source equals to 0. Fine. So yeah, so that doesn't look like a big problem. Okay, when I'm taking my distance as this, so I just want to refer to the solution which I have submitted. So distance as SRC, and after that I can just take this part. Okay. So what I can do is I can go with the SRC as 0, and this has to be 0. Okay. So once this is done, I will be initializing Q data structure of the type integer. Okay. Q equals to new. Just simply take this. That's why I don't like the editor of the GFG. I am going to take a new linked list, which will be helpful for storing unique values. Okay. So I will be adding q.add. First, I'm going to add the source. Okay. Now I'm going to traverse through it until the structure becomes empty. So q.is p ty empty. So over here, node equals to q.peak. Okay. q.remove. For after this, I will having int dot get node. Okay. In this, I'll be checking if my of the distance of the node, okay, plus 1 is lesser than distance of the current node, which is it. Okay. So I'll be having updating it. So it equals to 1 plus distance of node, and finally going to add q.add it. Okay. After this, I will be having another loop to go for the base case check of the remaining elements. So if lies any remaining elements which are not reachable, so I will be assigning it to infinity and return -1. So if the distance of I is equals to 1e9, okay, then distance of I minus equals to -1. Okay, my loop is complete. I can return the distance. Let's compile this. So yeah, we have successfully completed our problem, and make sure you guys like, share, and subscribe to the channel. And yeah, and this was a medium to hard level problem on because shortest path. The main concept you should know is you should be having an array list of adjacency list, which will store all the adjacent values. After that, you have to populate the list with this line of code. You can see then I have initialized the distance array with very large infinite values. After that, I'm having a queue data structure, which will, as you know, I have written over here, as I've written over here, fill this queue data structure. Similarly, it will be filled with the help of the queue data structure. Okay. So after that, we are going to add the source. Then we have to check whether that queue is empty, and then finally we have to remove the top elements, and so and so. We have to traverse to the list. We have to update it, and yeah. So let us submit it because of the internet issue. So it just got paused. I'm sure it's going to pass all the test cases, as it has passed the test cases earlier as well. But because of some internet issues, this is lagging a bit. So yeah, make sure you guys like, share, and subscribe to the channel. And thank you for staying in touch.